Well, welcome everyone. My name is Guy Royce, and with me today I have Zander Matheson. Zander is with Bytewax. Did I say that right?
Yeah, that's correct.
It's kind of obvious how to say it. Yeah, we were just discussing before I did this little introduction here. It's all very fancy. Is the W capitalized or not? And it was a resounding no. The W in Bytewax is lowercase.
Yeah,
and it's spelled byte like as in 8 bits, not byte as in
biting a sandwich.
Yeah, and I was going to go with an apple, but that's because I'm a Mac user, and that's just how we roll. But yeah. So welcome everyone to the show. We are. I'm with Redis. I'm a developer advocate, and we're doing a whole series of interviews with some of our partners, of which Bytewax is one. And so welcome, Zander.
Yeah, thanks, Guy. I'm really excited to be here. As my introduction stated, my name's Zander. I'm the founder and CEO of Bytewax, actually. So kind of do a little bit of everything. We're a small company. We're only a 10-person company. So at that stage, you can imagine I do all sorts of things. We're going to talk a little bit about Bytewax, what Bytewax is, so I won't get into that now. But excited to be here. I'm excited to partner with Redis. We had a blog post with Redis, and some of this touches on that blog post. You can find it on the Redis blog, and we might do a demo later. But I'll turn it back to Guy.
Yeah. So I was going to go with just sort of a straight up introduction. So you're CEO and multiple hat wearer at Bytewax, 10-person company. I actually have some experience working at companies at that scale as well. It's a lot of fun, and it's a lot of terror, and it's a lot of excitement.
Yeah, all the ups and all the downs.
Yeah. So tell me a little bit about what's your tech background. How did you what's your background just from a technology point of view in general, but also then how did you find yourself founding a company and doing this thing that you're doing?
Yeah, not such a direct path to where I am today. I originally attended college or university to become a civil engineer. It's kind of like was the back, the history of males in the Matheson family were all civil engineers. So it was kind of like I didn't have a choice, or I just didn't know anything else. So I became a civil engineer, started working as a civil engineer. I was working on hydrology stuff primarily. A lot of this was to understand how much water would fill up a valley so you could run a hydropower project, or how much water would fill up a valley so you could cover the tailings from mines so that they wouldn't oxidize and leach out bad things into the environment. So anyway, hydrology stuff is all very stochastic in nature, and I really always liked using the different kind of analytical methods involved in all the different practices in civil engineering. But I wasn't so enthused with civil engineering, so I went back to school, and I actually went to business school. And then this could get long-winded. I'll just keep going though. When I was in business school, we got plenty
of time. We can always cut it in post. Yeah.
Yeah. When I was in business school, it was when the title data scientist was coined, sort of, because there was the chief data science officer, DJ Patel, for the Obama administration. And so data science became this sort of thing. And I was like, oh, that's really cool. I'm in business. I'm studying business. I like to understand how businesses work and operate. Providing this hacking capability that I've always had, and this matching it with this a bit of a love of statistics, I should become a data scientist. So I tried to do that. So after I finished business school, all my friends were going into banking and consulting and all of these what seemed to me like horrendous jobs where they would sleep under the desks and work for 14 hours a day or something like that. I went and found a job where I could work with computers basically, and trying to do data-y things. It wasn't directly into data science. I ended up working at a speech technology company, really small speech technology. It was right at the time when neural networks were being applied to speech recognition. And so it was a really cool time to learn about that. And I got even more kind of enamored with what's possible with math and statistics at scale, at data scale, basically. And so I continued along that path. I then worked at 2 developer tools companies. I worked at Heroku and then at GitHub. And I was kind of like, I've always been a bit of a jack of all trades. So I did stuff from, data engineering, where at Heroku, I set up our first Airflow and worked on the first implementation of our data warehouse. And then I did data science stuff like clustering users coming through Heroku or optimizing our EC2 spend. And then at GitHub, I got more into machine learning infrastructure and more of the infrastructure path. So at some point I was managing a Kubernetes cluster and a bunch of infrastructure for the machine learning team there. So I really did all sorts of stuff. And how I ended up here running a company that develops a open source Python stream processor is that last job. I found out how difficult it is to do real-time machine learning. And so that's where the idea for Bytewax came from, to work on something in real-time machine learning space. And then we ended up with a Python stream processor.
Cool.
Yeah.
Excellent.
Long-winded, but that's how I got here today.
Well, it's an interesting background. You run into this quite a bit. I personally have kind of a boring background. I graduated high school and said I want to be a computer programmer when I grow up. And then I went to school and studied software. I got a computer science degree, and then I got a job, and then I wrote code for 30 years, and that's my career, right?
Yeah.
But you meet all these people along the way. I mean, there's people's like, oh, I have an English degree, and it turns out that doesn't pay that well. And so I went back and I went to a boot camp or whatever. And now I write software, and so it's always nice to hear these interesting stories of just how you find yourself there. It makes sense with an engineering background and the amount of math that goes into that. Specifically, like I said, a lot of statistics that you would find yourself in data science. It's a natural path to have gone down. Yeah, that's a really interesting. It's a really interesting story. I liked it a lot.
Thanks.
2 thumbs up. Would listen again. So you're CEO of Bytewax, which is a Python-based stream processing tool. An open source one. And so that's sort of a very short description of what it is, but you probably have a much longer and well-rehearsed description of what it is. So I like to ask the question is, what is Bytewax and why should I care?
Yeah. I don't know if I have the most well-rehearsed version of this, but the impetus behind the stream processor that is Bytewax was that our work, when I say Dan, who's a VP of engineering at Bytewax, we worked together at GitHub. So when we were at GitHub, there was a lot of friction in taking a machine learning model and putting it into production to make the inference in near real time or real time. And it's difficult because the data scientist, this is one perspective on why we develop Bytewax and why you should care about it if you're a machine learning person or enthusiast, but there are others too. But anyway, what you did to the data in order to train the model, you now need to get that same data, and then you will convert those into features. And you need to do that in real time. And a lot of that involves stream processing in some way, shape, or form, whether you're joining streams together, and a lot of it's stateful too. So you're joining streams together, or they're taking a window of time, or you're counting things. The one for a recommendation engine. So you have all of this data of how people click and interact with your website and ultimately buy things and what they've bought in the past, and all this different data that is both at rest and historical, and then coming in real time. And so you basically cut in time and say, I'm going to use all this historical data to train my model. And these are the features, basically these information bits. So you train that model, and then you're like, now I want to go in production. And I'm like, oh, I need to do to that data the same that I did in training, or in that training process. I need to do that in real time. So you're click streams, you can imagine, or updating products, and you need to merge all this stuff together, maybe take a window of time and look at a session, stuff like that. So that's where the
bucketing, all that kind of data engineering stuff that happens to.
Yeah.
So you can build a model. You also have to do it to do inferencing against the model.
Yeah. And so when you go to move from training the model to production, you are asked to swallow the Flink or Spark ecosystem in order to run what is a small little job. I just need to count a certain number of things on a stream of data. It's not like a crazy thing, but you need to take on all this infrastructure. All this is to say is that the value of Bytewax today is that there's less of that requirement of expertise and upskilling. So you can stay within the scope of what you're good at, and you have a really good developer experience. And so you can iterate really, really quickly with Bytewax over what is currently available. What makes it easy to use and what makes the developer experience so nice is that there's no scheduler or task manager or job manager that's this separate tool you need to understand. You just write some Python code, like you're writing a little Flask app or something like that, and you run it. And that's it. You don't need to ship it off to a cluster that someone else is maintaining and figure out how to get it in the right queue for the right job or all that stuff. You don't need to worry about that. So that's a big part of the developer experience. Why if you are doing stream processing, you should care about it. If you're not doing stream processing and you're not doing machine learning, then maybe you don't need to care about it. So
I actually, before I, this morning when I prepped for this interview, I was reviewing a lot of the material on your website, and one of the things that really struck me about the code on there is how intuitive and straightforward it was. It's just do this, transform it to this, transform it to this, transfer this. I was going through the. I think we're going to demo it later. Maybe not, but it was you used time zones as a proxy for region, and used the whether they were a mobile user or not, and then there's some time aggregation in there, and but reading the code was very intuitive. I could just read it, and it seemed very declarative. I was like, transform it this way, not transform it this way, not transform it this way. So I think that's a great developer experience. And that was my impression as well. So I guess I'm complimenting you to say that I think you've succeeded in creating a good developer experience.
The API design is something that we it's always we're talking about.
Absolutely.
And how to make it more intuitive. It's every single day. But I think what you really like from it, which is interesting, is the functional nature. It almost feels functional. It's and many of the stream processors actually have their Scala, etc. So they have this functional programming history to them. And there isn't that much of that in Python, but Python is super readable. So if you put functional, which really makes sense because you're I did this and then I did that, and you're saying, and you add on the Python super readable syntax, it just feels really nice.
It honestly kind of reminds me, my go-to language, and you may judge me for this, is JavaScript.
No judgment.
No judgment, right? And JavaScript has these sorts of, you got map and reduce and some basic functions for working with arrays of data. And it has, you can chain them kind of tidily in JavaScript, but there's often a const foo equals result of doing some transformation over an array, and then const bar is a result of doing a transformation over that, then return foo, just because it makes the code more readable, and it doesn't really have a big performance implication. Readability in my mind is almost more important than performance. It isn't always, but there are times when it's a good trade-off. Whereas I've used other more functional programming languages, I don't know if you've ever looked at Elixir. It's a little esoteric, but it's got that pure sort of that piping where you take a result and you pipe it into something, you pipe it into something, you pipe it into something, you build these sort of chains that are very much like a Unix command line kind of stuff. And but it all feels functional, and I think stream processing is intrinsically a functional thing. That metaphor works perfectly.
We were actually, it's funny that you bring up the pipe. We were thinking of overriding that in the last change. So when we added joins to the library, we had to figure out it because before we had this the syntax where it was, you have the object and you're just kind of adding to it. Dot do this, dot do that, dot do that. And when we add joins, we're okay, we have multiple streams in this flow. We need to be able to address these individually, and we wanted to have a lot of type hinting and stuff, and like add that in to make it more friendly to use. So we moved from the syntax to this other syntax, and we were thinking about overriding the pipe so that you could go like, do this pipe, do that pipe, and we ended up not doing that for now. I mean, it's always something we could add in, but now we just added a verb, so it's like, do this, then do this, then do that, instead of the pipe. But the pipe would have been fun, I think.
So yeah, I think I mean, I think I said this already, but functional is a good metaphor for this kind of stuff. And you know, people can debate whether JavaScript is a functional language or not, but it certainly does have functional features. I would not call it a functional language per se, but it does have functional features. And so, that always kind of resonates with me.
Yeah.
Let's look up another question here. So, so what makes Bytewax special? What's makes it better than other tools that do similar things?
So I think I kind of mentioned it in a very long-winded way, but what makes it special is that in comparison to existing stream processors, which you might think of Flink or Spark structured streaming or Kafka streams, and there are also a bunch of newer companies and projects that have come up that are trying to tackle this, and some of them are at very different stages of maturity or providing different offerings of what they have. But so I think the thing that makes Bytewax so special is a like combination of Python really and this developer experience, which we can get because we don't have there's no task manager, job manager, scheduler, orchestrator. We use this like execution / runtime engine called Timely Data Flow that's underneath. It's a Rust library, and it's almost like you can think of it as self-organizing. So if you distribute your work across multiple processes or threads, there's no one telling which work goes where because it's a data parallel approach, and all the same operations happening on each worker. And so those workers only need to communicate between each other when there's something stateful going on to make sure the right data lands on the right place. And so this is a very complicated way to say that because of that self-organization, you can get that feeling of just running a file of Python code, and there's no outside infrastructure that you need to manage and maintain. And that allows you to write tests, it allows you to run locally, iterate very quickly, and then when you go to production, it's the exact same code, and you can scale it really seamlessly.
Fans out.
Yeah, and we also took advantage of the fact that, hey, all of these great projects that exist that are they're amazing, they can scale, they're so battle tested. They were written, 10, 12, 13 years ago before cloud native was the thing. So let's take advantage of cloud native so we can take advantage of Kubernetes. And so when you want to scale Bytewax, because it is cloud native, you can easily scale it across a Kubernetes cluster. And once again, you're taking advantage of a stack people already know. And so it's just a way we think, there's also like all this like little sugar bits around the API and stuff, but it's like all the things you need for a proper stream processor, the right guarantees, the ability to distribute data, the ability to do state joins, all the table stakes, and a very delightful experience makes it just easy for anyone to do stream processing instead of having to be an expert in order to do one thing. So that was it. That's the special. Yeah, I think.
I think that's a good strategy. I think that's a good angle. And I sort of said this earlier, but the developer experience, I want to say it again because I think it's really important. Is the developer experience it is really good. When I looked at it, I'm like, this is very intuitive, but then it can scale at the same time. But developer experience is so important. It is literally the surface at which people interact with the product. And so it is just, that is the most important thing that any product that any developer tool is going to use, where you're integrating with some sort of API or library. That has to be designed thoughtfully and intuitively so the developer can look at it and just understand it. That is so valuable. So
yeah, the way I look at it is like you have a certain number of boxes you have to check to like meet. But those boxes, if you overcheck them, it doesn't mean it's that much better. So there's a performance box, and you have to check that box. And there's a feature box, and you have to check that box. But with the developer experience, there's a spectrum. It's not a checkbox. And so you can create more and more and more and more value for the end user by making it better and better and better experience. So at the end of the day, I think like there's like the requirements you have to build, and then what really keeps people around and makes people excited is that it's fun to build with. It's like you got to do some things, but then the rest of it is like that's what differentiates you in the end of it.
Yeah, there's always this tension with the developer experience too, where and you see this in products over and over again, where this is experience in any product, not just a developer product, where the developers ask or users ask for more features, and then you sort of get into this scenario where, well, this was this beautiful, clean, easy to understand thing where the developer experience is great, and then you pass in this massive config thing, or it's got all these exceptions that can be, and it gets hard to understand. And it's an art to balance those two, because if you take it too far in one direction, then it gets complicated really quick. And if you take it too far in the other direction, then you're telling users what they need, not them telling you what they need. And so there's an art to balancing that.
This sort of like opinion versus like too many dials.
It's the highly opinionated code versus the highly configurable code. They both have a flaw. The highly opinionated code can't solve certain problems. The highly configurable code becomes too complex, and striking that balance is hard. It's actually a challenge, because you will. You'll get these pressures as a company where it's like, well, we could just land this deal with this really big company if we just add this one feature that they really want, and then and then you do that 4 or 5 times or 20 times, and then you end up with this Franken design that is just hard to work with. And navigating all that. I mean, you're a 10-person company, so obviously that's not going to be the same sort of challenge for you. Well, but in some ways it can be as well, because it's like, well, but landing a big client, that's a lot of money, and this could be the difference between existing and not existing. And I mean, that could be serious stakes when you're small. So it's always challenging. It's always a challenge to balance this out.
Yeah, for sure. I mean, one thing we can lean on a bit there is open source versus our commercial offering. And many of the big companies will want things that will be in the commercial offering that maybe don't help anyone else. If you're using the open source, you might not care about some compliance feature, or you might not care about some, I don't know, certain drag and drop UI thing. And so hopefully we can keep the open source quite lean and mean. And the platform will have all of the features that you want when you start to scale and you run it in an organization, and you have a ton of checkboxes that you need to check.
Yeah.
I mean, it's probably similar to Redis and Redis Enterprise, right? You have a bunch of checkboxes in Redis Enterprise, and you want to provide value to the right people. And sometimes that's one thing for one big company that you're like, well, they've been an existing customer forever, or maybe we want them to be a customer. We just got to do it. Yeah.
If we could just, give us one feature, we could land that whale. Yeah.
We always think if we get this one feature and land that whale, will we survive? It's like, will we survive as the humans trying to maintain the support for this company? Will we actually survive? And that's what we talk about.
Yeah. So we talked a little bit about your history. What's Bytewax's origin story? How long have you been around? How do you land on the idea of doing this? I think you did talk about this a little bit, but why did you call it Bytewax?
Yeah. So
other than that, the domain was available.
Yeah. I think when you make up the word, the domain's available always. The 2-year anniversary of the open source project, I think, is like next week, maybe, or maybe it's this week. I should probably know that.
We should release this on the 2-year anniversary.
Yeah.
We'll have this edited in time.
yeah. In February sometime we open sourced, but we had been working on the idea and the company for a bit before that. So the company's like, just over 2.5 years old. Like I said before, I was working at GitHub, came across this friction with real-time machine learning, how to put a model into to have real-time inference, and then ask the whole data science team to go learn Flink and Java and Scala and then troubleshoot the JVM, and it's just not going to happen. So that's kind of why Bytewax existed. So we're like, okay, real-time machine learning is hard. We tried a few things, and what we keep coming across was people wanted to do real-time feature transformations, and in order to do those, you need to have a stateful stream processor, because you'll do all the things that a stateful stream processor can do. So that's that. And then the name was really just there's a couple little like stories, but the one I go with is, so I have a ski racing background. When you wax your skis, it allows them to glide frictionless or nearly frictionless along the snow. And so you can think of bytes, sliding across, frictionless. So that's one way you can think about it. And ended up, with like a whole honey thing in there, and beeswax, and so honeycombs, and we kind of ran with it, the whole bee theme. So we have like chunky bee, and we have a lot of gold on the website, a lot of hexagons. We have workers. We should probably say there's like a queen node and the worker nodes, and the drone nodes. But there's this kind of cool thing about the whole like self-organizing-ness of the hive mind or whatever, and that's kind of fun when you think about how the different workers in Bytewax, they sort of self-organize and intercommunicate between each other but there's no like explicit leader. So it's kind of neat. It's like a bee thing.
That whole merchant behavior thing.
Yeah, exactly. So bees are cool. Bytewax is Bytewax. Skiing's cool too. So here we are.
There's always an interesting story in company names. And getting that domain name is useful too. Redis's story is way less interesting. It just stands for Remote Dictionary Server.
Yeah,
that's it, right?
Yeah.
I did work for a startup who was later purchased by another startup, and we took our. I could say the name. It's not in business anymore. The company was called Nexosis. It was a machine learning API, and the idea was you upload like a CSV file, and then it'll build all the models for you, and then rank them, and then give you an endpoint that you call to invoke them. That was the idea of it. And it was a combination of Nexus, meaning like Nexus, and Gnosis, which is like the Greek word for knowledge. So it was like the Nexus of knowledge. Yeah. But it ended up just sounding like a skin disease.
Oh, it's so good. Nexosis, yeah.
And so Eric, sorry if you're out there watching, it does kind of sound like a skin disease. So Bytewax works really well. It doesn't have any weird skin disease connotations, so I think you're doing the right thing.
Yeah, it's nice because
there was thought in it, though. That, and there's always that story, which is why I like to ask this question. It's like, why'd you name it that? Where did that come from? And there's usually some interesting story.
People seem to remember it, and there aren't other Bytewaxes. Like, there's nothing to confuse it with, so that's kind of nice.
So, who's using Bytewax? I'm not necessarily asking for your client list, but who, from a developer perspective, you've probably touched on this quite a bit already in some of the other things we've talked about. But who's using it? What kind of things are people building? I mean, obviously, people doing real-time AI with this, where you're building that stream. But you could use this for a lot of other things as well. I mean, any kind of stream processing system is eminently suitable to the whole idea of the this kind of it feels like a data term to say ETL, but that extract, transform, and load sort of process is sort of a precursor to a lot of the tools we use today. You can certainly use it for those sorts of things. It's got a lot of, I mean, even just as sort of a functional library to transform stuff, it seems like it could be intrinsically useful just as a developer who isn't necessarily doing stream processing, just wants to do step-by-step data transformation. So who else is using this? What are they using it for?
Yeah, you could use and or abuse Bytewax for many different use cases. No,
I may have said some abusive scenarios myself there as I'm spitballing here.
So it's because it's such a generally applicable stream processing tool. There's a ton of different use cases. Most of the use cases that we feel best fit Bytewax are those where there's like some sort of operational logic that you're doing, because there are many tools that you can use to shift data from E to B in a real-time-ish manner. And there's not a lot of complex things going on. And so and it's very like schematized. And so maybe something like more declarative works there. So generally it's these more operational workloads where the theme seems to be largely around, hey, I have a bunch of incoming streams of data that represent a system. I need to monitor that system and I need to react to it in real time, whether that be a fleet of logistics, vehicles, or sensors in a warehouse, or a financial system, like a bunch of transactions, or a website. So there's many different use cases. One thing that we didn't foresee when we started building Bytewax was the applicability of Bytewax for edge use cases. So running Bytewax at the edge as a stream processor, because it's such a small footprint in comparison to Flink or the others, because you have no direct reliance on Kafka, no reliance on the JVM, and so there's a lot smaller footprint. We get a lot of people using Bytewax in very interesting places, running it on ships, deploying it in the field for like sensor analysis. But yeah, a lot of edge IoT, financial industries, like use cases there. Folks are using it for monitoring transactions or for not high frequency trading. It's not most suitable for that, but for algorithmic approaches to trading, where you need real time, you're doing Python stuff, you're doing statistical stuff. So it fits well. Cybersecurity area, monitoring, etc. Machine learning stuff, which is more broadly applied. So you have anomaly detection, which can be for manufacturing, or it can be for fraud, or it can be for various different use cases. You have recommendation engines. So, how you're feeding the data in for the recommendations, and that has a lot of different applications, but a lot of e-commerce, personalization, stuff like that. There are some really cool users in our community doing interesting stuff with energy grid, like I said, running Bytewax on ships, digital signal processing for satellite data. It's really, really cool stuff. I mean, some of it I'm like, I don't know, your use case is really interesting and cool, and I just want to learn about it. So tell me what you're doing, because I don't know anything about it. There's some people doing some stuff around crypto trading or providing platforms to do crypto. All over the place. Some government stuff, which I don't know really what it is, but it's open source. So people just, they find it, and they use it. So
this is actually kind of a good segue to another question I wanted to ask. You mentioned people are deploying it on chips. It's on the edge. It's in all kinds of interesting places. You've got this ability to fan out. I know you have a SaaS version of this as well, a platform where you can run this. You want to talk a little bit about that? You want to sell everyone why they should use that?
Yes. Well, it's not hosted right now. It's self-hosted. Runs on top of Kubernetes. We chose to go self-hosted first just because of the nature of streaming data. It's generally quite quite sensitive, and you want it quite close because you have normally there's some sort of latency requirement. So we made it as easy as possible to run this platform on top of Kubernetes in your own cloud or in your own infrastructure. So Bytewax, like a single Bytewax stream processing workload, can run anywhere you can run Python. Raspberry Pi, a VM somewhere, your local machine. When you use the platform, when the platform gives you a lot of like operational nice to haves or must haves, authentication, a UI, disaster recovery, scalability, multi-node deployments, runs on top. That all runs on top of Kubernetes. So you're limited to where Kubernetes can run, which these days it can run quite a lot of places. So we have, you can K3S, which is like a small binarized Kubernetes, allows you to run that on the edge and deploy it in air-gapped or network-constrained environments too. So, yeah, I mean, it's kind of true to the name. You can run Kubernetes in very many places today, and you can run the Bytewax very many places today and deploy it very easily. So.
Well, we've talked a lot about what it can do and how it works and everything. Yeah. I think it might be time to see some code.
Sure.
This is intended for developer audience. So developers out there, I'm looking at you. I know you want to see, is this thing real or are we just talking about stuff? Do you mind? I know you've got a demo ready to show off. Would you like to show it off?
Yeah, I will run a quick little demo. What I'll demo is what's in the blog post that's on the Redis blog. So if you want to go dive into the code yourself, it will be there.
And we'll have those links in the notes in the description of the video here. So along with links to all the stuff that we talk about. So except Nexosis.
Okay, I'm going to share now. All right, so we'll start by poking around a little bit with the code, and we'll try to understand what we're trying to do here. Okay, so what we're going to try to do here is we're going to simulate a click stream. So we have a JSON lines here, a file with some click ID, the OS the click came from, some time zone information, device type, et cetera, et cetera. So pretty like standard stuff. And this is just going to be a stream of data as people interact with the website. And we're just mocking it up here. And there's, I don't know, a few hundred or 1,000. We're going to use Redis PubSub. We're not using Redis streams right now, just using PubSub. It's the earlier iteration with different guarantees, but it's suitable for this, and you should be able to modify it to streams if you wanted to. So we're going to run Redis, then we're going to do this all locally. So we're going to run Redis, and I'm going to show you a data flow, and that data flow is just going to literally just read out what's being put into Redis PubSub. And so we're going to write all these. We have this little publisher helper here. It's all it's doing is connecting to Redis and publishing those lines on the channel. And then we have
easiest code ever, right?
Yeah, that one is very, very easy. So this is if this is your first time seeing Bytewax, we're doing something a little special in here. The kind of crux of the code here is just 3 lines really, where we're creating a data flow, and then we're reading from Redis, and then we're just going to write its standard out. So this is just an echo, and then we'll move on to the more complicated version. In order to do this, though, we had to make a custom connector. So connectors in Bytewax are the input sources and the output sinks. And we have a few built-in sources and sinks, but the nice part is whenever you want, you can jump into the input and output API, and you can write your own inputs and outputs. And it gives you all the handles to do things like await for a new batch, or change the rate at which you pull for new information, for new data. You can set the partition. So if you have a partitionable input or output mechanism, you can hook up workers to partitions, and really do everything you need. You can also snapshot the progress. So if you have a recoverable input source, something that you can rewind to, like in Kafka, and you can replay that, you can rewind to the right place. Basically what we do is in a stateful data flow, You want to recover state at the right place so it matches up with progress. So this is part of how you get the right guarantees, exactly once, at least once or most once. For this, we're not using recovery, and this is a super simple data flow. So we'll start here. So first thing we'll do is we'll run Redis, which may already be, looks like I just removed it from this one. Here we go. So, it maybe already is running. Okay, I already have Redis running, so that's good. So I'm going to start the data flow, and the data flow will start listening to that Redis channel, and then we'll publish some data there. So to run Bytewax, like I said, it's just like running your Flask app or your Fast API, where we're just using a Bytewax run module to run our file, and our file is called data flow echo. And similar to Flask or Fast API, you can set the specific module inside. So, or you can not, but for this instance, we will. Here, if I wanted to run this with many workers, I would just scale up the number of workers. And if I wanted to run it in many processes, I would set different processes up and they would communicate together. So, all right, so our data flow is running. And then over here, we're going to run the Redis publish one. All right, so let's publish some data. Cool, and now you can see it echoing out on the other side. So nothing special here. All we have done is listened. It's just an echo. We will take the next step here to showcase what we actually want to do, which is we want to count the number of users in each region. And so we're going to make another data flow that actually does more than just print it out. So we have a data flow already written here. We're defining our input source. So we have this stream handle, and then we're going to deserialize that data because it's a JSON payload. And then we're going to key the stream with a function. So the way that Bytewax works is you have operators. You have map operators, you can have window operators, you can have different types of input operators, output operators. So you have different operators, and they sort of control the flow of the data. And then the transformation happens via the Python function that you pass within. So we are setting up an initial count so that we can add these things all together by pulling the OS time zone. And then we have the int value of the device is mobile. So we're counting the number of mobile devices per region. And we're going to do that over a window. Here we're using the system clock, but you can also use event time too. And there's just like a little parse function, but we don't have event time in our JSON line. So we're going to just use the system clock. And every 5 seconds, we will sum, which we're using add function, over the key. So you have 5-second interval for each key, how many devices clicked. And then we'll format that and then we can print it out. So we'll go and run this one. So now we can publish again and we'll see a different output on the screen here. So we counted up all these things and printed them out. So we have the time zone, the number of mobile users, window metadata, and then the actual value. So the window metadata says the open time was 20:35:10 UTC and the close time was 20:35:15 UTC, and there were 27 users in that 5-second window. So we can see the different time windows. Everything basically happened within, I think, 1, maybe 2 time windows. Looks like just 1. So that'll work. That's cool. We've done what we wanted to do, and we could run it all locally, and we had 0 additional infrastructure. I mean, we're running Redis, but other than that, we have no other infrastructure. So we can do stream processing.
And the Redis code didn't have to change. I mean, so the source is still the source.
Yeah. So the one other thing I wanted to show. Wait, do you have any questions? Sorry, I cut you.
No, that was all. I'm helping.
Yeah.
That was just an observation where you changed the the output and all the transformations, but the core thing that's generating all these data and shoving them to Redis, the pub sub comes in and it does what it does.
Yeah.
And you could have two of these running doing two different things as well, and they'd be consuming that same source.
Yeah, what's always so fun about using Redis is just how straightforward it is. Simple, but you can get some pretty serious power. That's why I always like using Redis.
I think that actually is how it gets its powers, because of the simplicity. That's sort of it's got a single thread that everything's on, and internally it's data structures behind a wire protocol, and it's just get in, get out, do your thing.
Yeah. So let's say we're really happy with what we've developed so far, and we want to be able to use Bytewax more across our organization or within our team, and we want to start to figure out a way to manage things. So say we had all these Python files running somewhere, or Python scripts running somewhere. They're long running, so we'd have to build all this kind of operational infrastructure to manage that. And so what I'll show next is the platform, and so we've built that for you with our, using our experience and expertise. And so I have a cluster running, and we have a command line tool. The command line tool is called Wax Control. So if I have a cluster right now running, and if I was to use Wax Control, I can list the data flows running in my, that are in the command. Let's do all. They're running in the, let's also make this a little bigger so people can actually see. We're not going to be doing much code.
You can click the little chevron there too, and it'll put it all the way to the top.
There you go. Well, we'll keep that. I might need to copy and paste something there because I don't always remember everything. So we have 3 data flows running already in here. There's one that's aggregating stuff from Red Panda to S3. Looks like it's been running since June 2022. That's something we use internally on this demo cluster. This is a split demo. It just shows how to branch. And then this is WikiStream one. So this is reading from WikiStream and parsing the data. So you can kind of see what they are, the Python file. And this is where we could deploy our new data flow from. There's also a UI where you can see these different things. So you can click into it and you can see the data flow, and you just have all these pretty things here. You can understand what's going on, and we're continuing to build on this. But let's go ahead and deploy a data flow. So the first thing, I am going to need to do some copy pasting here because I do not want to write this all out. So what we're going to do now is deploy a data flow. I have Redis running in the same cluster. So what I'm doing is getting the password from that Redis running in that Kubernetes cluster where the platform is running. And I'm going to set that here, and I'm going to set that also here. So now in my now when I go and use that, so now what I'm going to do is run the data flow remotely on the cluster. And then locally here, I'm going to start shooting off some of these click streams as if I'm going nuts and clicking everything. So the first thing we'll do is we'll deploy with Wax Control, and I will copy and paste the command here. Oops. So I'll walk through what this means. So Wax Control, data flow, deploy. So the way that the data flows work when you're deploying remotely is there's an image that you're going to use. I've already made this image and pushed it up to a registry in AWS. And then I'm going to tar the files I need, the Python files and any data or any other artifacts. And I'm going to basically push these things up to my cluster and run it. And I can give it a bunch of different things that I might need here. Here I'm augmenting an environment variable in that YAML file. I'm tagging it Redis Bytewax v1. This is the actual name of the file that I want to run, which is dataflow mobile accounts py that we just ran locally. And then I'm specifying the demo Redis host name for the internal cluster. And I'm going to run it in the namespace demo, which is my Kubernetes. It's the same as a Kubernetes namespace, but it's the platform namespace. So if we deploy this thing, so dataflow mobile account is deployed in the demo namespace. In the demo namespace, I now have the mobile account demo running. And I can see my file, I can see the image, and it's been running for, I don't know, 30 seconds or a minute or whatever it is now. So now that we have that running, we're going to do something called port forwarding. If you don't know what port forwarding is, it's just an easy way to expose a Kubernetes port. Well, with respect to Kubernetes, expose a Kubernetes port so that we can use it as if it was locally on our machine. And so I'm going to run a command that will port forward the, I'm going to copy paste as well. That will port forward the internal Redis in Kubernetes to localhost 6379. All right, we're port forwarding. We can minimize this. And now we're going to push the JSON lines up, and then we'll go look at the output in the data flow. So we have this data flow. Oh, we'll refresh this. So we have our mobile count. It's waiting. Nothing's come out of it yet. We can see the different steps. Cool, cool, cool. We'll go back here, and we're going to run our source/publishing Redis publish. And this will be slower than when we ran it locally because it's doing a network hop on every single connection and every time it sends up. But eventually we get some output. So we have click streams coming through, and we have aggregations happening in real time. And that pretty much sums up the demo for now. That's how you use Bytewax locally, and then how you run it. And this would be something that could run in production. I mean, obviously you might have some sort of CI/CD setup, and you wouldn't be using a port forward. But yeah.
So it's real.
Yeah, it's real.
Always important.
And I'll stub this in now because I was going to stub it at some point. I think we maybe hit 1,000 stars today, so that's pretty exciting on GitHub.
Nice.
And if you're watching this, we always appreciate stars. It makes people think that the project is authentic and worth their time they spend to learn about it. So if you like it, give us some love.
Absolutely, you should. And we'll make sure there's a link to the project out there in the show notes down below as well. So that you can easily go and click that star.
Yeah.
Just like you're going to click like and subscribe on this video, right?
Yeah. Of course. Yeah.
I'll see if I can get the editors to put a little, a video there at that moment. I mean, it's a simple demo. But it shows off all the things you can do, right? I built a lot of demos myself, and it's a great demo to get someone started who wants to learn. Well, sort of one of the questions I came in with, which is what's Bytewax and why do I care? Well, this is the demo. This is the thing that you should do to answer that question. I mean, aside from your answer, if you want to go out there and actually kick the tires on it and do it, this is a great place to start. So, I don't know. I'm looking at the rest of my questions we got here, and I think we've covered most of them just in conversation. Is there anything you got in the works that you want to hint about? Maybe I hear that there's some AI type of stuff that you might be working on. That isn't quite ready that we might have in a future interview or a future live stream, maybe.
Yeah, I hope so.
He asked knowingly, right?
Yeah. So I last year I gave a couple talks about real-time retrieval augmented generation architecture for LLMs because a stream processor is a really nice tool to use there because it's basically your like ingestion for search and retrieval, basically. So it's how can you ingest the most up-to-date information in a reliable way and put it somewhere that you can retrieve it. And so I did that talk, gave that talk at Scale by the Bay, which is in November. And that was using Redis with the vector index and the new Redis VL library, which a bunch of folks at Redis worked very hard on, and it's really fun to play around with. So that yeah, I'm trying to put the final touches on a little blog post that's shows you how to use real-time data in concert with large language models for like a RAG architecture, which is great for instances where your data is updating all the time and you need to have the most relevant information provided back to the user. So financial news or just news in general, or maybe it's ongoing conversations for kind of Q&A or sorry, not Q&A, service and support. Different kind of in different situations, you want that data to be made readily available immediately in an asynchronous way. So it's not you start the chat, it loads all the things in. Like, it's not like like that. Oh, tell me what this PDF says, which is also kind of RAG, but it's a little different. So it's like you have a continuous RAG pipeline that's putting, financial, 10Ks or 8Ks or quarterly reports or, whatever else they have. And then you always have all the financial news streams coming from Benzinga or Bloomberg, and you kind of put all this data somewhere in a way that you can actually retrieve it and synthesize it and use it within the LLM. So that's kind of cool. We have like a blog post that's going to come out, uses Redis and Bytewax and some other Python libraries and some cool stuff like Hugging Face models. So that's worth checking out.
Absolutely. So I think I'll end with a question that I like to ask, which is, what didn't I ask you about that you think I should have? What do you? It's sort of an open invitation to talk about anything that I might have missed. So what's something I missed here? Something that you really think everyone needs to hear?
So, funnily enough, this is the question I did not do any preparation for because I didn't quite have enough time. Oh gosh, I don't know. This is too open-ended. What do I want other people to know? About Bytewax or about life in general?
You can go anywhere you want with it. I don't have any strong opinions there. I've kind
Usually
of
this is
about Bytewax, but you can wax poetic about just programming in general. I mean, because there's certainly going to be an overlap and intersection between what you're doing with your company versus what you think about programming. So,
well, maybe I'll keep it Bytewax specific. So this is my first time starting a company, and there's a lot of like things you learn and ups and downs, and the perspective most people have from the outside is like, oh, these people should be doing it this way, or why didn't you think about that? And that information doesn't always make it to me. And so what I'll leave with is like, I'm available on Slack or LinkedIn or whatever. And I love to find out from other people about things we should think about, things we should, whether it's with respect to open source or running a company. And so hit me up if you have any feedback, because I'm always available and I really appreciate feedback.
Do you have a preferred platform for that that you'd like people to reach out to you on?
Well, I'm literally like hooked into our community Slack channel like 24/7. It feels like, so that might be the best way. But also LinkedIn is a pretty friendly way to reach me. So Twitter and if you send me a DM on Twitter, I like never go on Twitter. I turn off notifications of Twitter. I like can't stand getting notifications from Twitter. So if you didn't DM me on Twitter, I probably won't ever read it, but LinkedIn I will for sure.
So LinkedIn for sure, and join the Slack if you're curious about this product. And I assume you can go to the Slack and get like just sort of some community level support where, hey, I'm using this thing, trying to do this. Anyone know why my code's not working, and that sort of thing.
We get lots of cool questions, and there's a bunch of really interesting people in the community. So definitely, if you're building something, come join. Excellent.
Well, I think that probably about wraps it up. You got any questions for me while you've got my attention?
How long until you start using Bytewax?
My inclination is to go play with it as soon as we're done with this recording. And I'm actually working on some projects where I could see it would be very relevant. We're building some demos out and stuff, and cool. I can see this being really useful. I'm doing stuff in JavaScript right now, so obviously I'm not going to be using Bytewax for that. But that gear is rolling in the back of my head about what I could use this for, and one of the things I like to do here at Redis is I try to live stream as much as I can, about 2 times a week, if I can maintain that schedule. And so wouldn't be surprised if I come up with a project that incorporates it. And honestly, if you'd like to join me on that live stream, we could do that if you've got the time. I realize you're wearing a lot of hats and you're probably pretty busy, but
sounds fun. I have a Raspberry Pi that I used to have this like hobby project on that I want to run the Bytewax platform on and then set up some sensors with. If I get that partially set up, maybe we can do a live stream and we can get that thing working together. That would be fun. That would be a lot of fun.
So, well, we'll discuss the details of, I'm already formulating an idea for a project we could work on that I think you might find extra fun, but I'm not going to reveal it in this interview. And so we'll discuss the details of that afterwards.
Sounds good.
Mostly because if I start talking about it, I'll talk about it for 10 minutes and the video will go too long. Nobody wants that. But yeah, well, I think with that, thank you very much, Zander. It's a pleasure having you here on the show. And hopefully we'll have you on again sometime soon, and we'll do some other content together. So
awesome. Thank you so much. Thanks for having me.
Absolutely. Have a great day.
You too. Bye-bye.